Hello, my dear students. This is Shadil Qasas, Head of Science Department, Sharjah American International School. And today we are going to continue our revision related to Grade 12, Electromagnetism. In our previous revision, we covered most of the theoretical part, which is related to defining most of the physical quantities that we have calculated. We compared between units and we derived some of them. We stated and explained the properties of a charge, like charges repel, unlike charges attract, and also we discussed the meaning of conservation, which means that charges are conserved, or the amount of negative charge should be equal to the amount of positive charge. We compared between insulators and conductors, and we said that the insulators are having very high very low resistivity or resistance, and very high resistance, and the conductors are having very low resistance. That's why conductors are better in conducting electricity. Insulators are like plastics and conductors like metals. We compared between different methods of separating charge, like conduction, induction, and polarization. We recognize the direction of the electric field lines if there are two positive charges in front of each other, or two negative charges, or one positive and one negative. We recognize the direction of the electric force between charges, and we recognize the structure of electric circuit, the parallel and series. We defined the role of the voltmeter and ammeter. We said that the voltmeter is measuring the volt and the ammeter is measuring the amperes or the current. Today we are going to solve some problems, and we are going to have some perspectives about how to solve the word problems or drawing problems. So the better way or the best way to do that is through questions. So these are some questions that you had during your tests and quizzes. And the first question is, the figure shown on the right demonstrates charging by. And if you look here to this shape, you'll find, or to this figure, you will find that there is here an insulator, and here he's telling you that there are induced charges, and this is a charged object, and it is very clear that the charged object doesn't touch the insulator, which means that it's an indirect charge or rearrangement of a charge, but without direct contact, and it is for insulator. So this is the definition of polarization. If this particle here or this part is a conductor, so it would be an induction process. The strength of an electric field around a charged object depends on both magnitude of charge and, so look carefully here, the electric field, which is E. So we can say E around charged object depends on. So recall the E. E is equal to what? E was equal to F over Q. Or if you have a drawing, it is E equals to Kc Q over R squared. So this question is related to those rules, one of them. So around the charge object depends on both the magnitude of the charge, so the magnitude of the charge, which is Q, and the magnitude of test charge, the sign of the test charge, the distance from the object, the volume of the space. So once he didn't mention the force, this means that it depends on the Q and the distance from the charge. So it depends on the magnitude of the charge, which is Q, and the distance from the object. The process of charging a conductor by bringing it near, close, or with no direct contact, and it's a conductor. So this means you are going directly to the induction process. The diagram on the right shows the electric field lines around two charges. Here a charge and another charge that I don't know its sign, whether it's a positive or a negative charge. So near to each other. Okay, from the diagram you can infer, you can conclude that the charge on the left is a positive or negative charge. So you need to identify two things: whether it's negative or positive, or whether whether it's bigger or smaller. So look at the charge carefully and decide whether it's positive or negative. I can decide this from the direction of the field lines, and as you can see, the directions are outward. If it's a negative charge, it would be like that, but these lines are outward. So it's a positive charge. This means that I will not look at A and B because it says negative. So it's a positive charge. So is it a positive charge smaller or larger? This depends on the lines. Are the lines bigger or smaller? So as you can see, this is so obvious that it is positive and larger because the amount of lines are bigger. So it is D. What is the most correct statement regarding the drawing of the electric field? Electric field lines always connect from one charge to one charge to another. Electric field lines always form closed loops. Electric field lines can start on one charge of either polarity. Electric field lines never cross each other. And as you can see, basically D is the right answer because they never cross out. Basically C is wrong because they cannot start from each polarity or either polarity because it ends at the negative charge. It doesn't start from a negative charge. Electric field lines always form closed loops. This is wrong. They don't form closed loops. And electric field lines always connect from one charge to another. No, because this is not the case if there are two positive charges. Charge is most easily transferred in easily transferred. So this is a conduction process. And easily transferred, this is a non-conductor. Is it easily transferred or semiconductor, insulator, conductor? So basically it is a conductor because it is easily to be transferred. What happens when a rubber rod is rubbed with a piece of fur, giving it a negative charge? So if the rod became negative, this means that the piece of fur became positive. So protons are added to the rod. Basically, when the rod became negative, does this mean that the protons added to the rod? This is wrong. We don't add or take protons by any means. Electrons are added to the rod. The fur gets negatively charged. This is wrong. The fur is left neutral. This is wrong. So the right answer is the electrons are added to the rod and electrons are taken from the fur. We are not dealing with protons by any means. 2-point charge, initially 2 centimeters. So I'm dealing with distances here. And then they moved apart with the distance 10 centimeters. So Q1 and Q2, they were 2 centimeters apart, and then they became 10 centimeters apart. So you're dealing with a value, or you need to compare the 10 to the 2. What is the ratio between 10 and 2? So it is 10 divided by 2. This means that the distance is increased 5 times. So R increased with 5 times. What is the relationship? What would be the force, the new force? And we know that the force is directly proportional with Q1 and Q2 and inversely proportional with 1 over R square. Don't forget the square value, which means that F is directly proportional with 1 over 5 square, which means that it is going to be decreased with a value of 1 over 25. 1 over 25. 25. So this is logic, because when you get two charges apart, this means that you are decreasing the value of the force. If you're doing the opposite, if the distance was 10 centimeters and it became 2 centimeters, you decreased it, this means that the charge is going to increase 25 times. Compare between the terms, between the following terms, conductors and insulators, and we mentioned this in our previous revision. Conductors means, the conductor means it's a material that is easily or that has low resistance and allows the electrons to move through. And insulators, they have high resistance and they don't allow the charge to move through. So this this is low resistance, and they allow the charge to move easily. Here it is high resistance and they don't allow the charge to move. Examples: conductors could be any metal, any kind of conductor. It could be any metal, copper, aluminum, iron. Insulators could be wood, glass, or plastic. Conduction and induction, we also defined these before. Conduction and induction, they are methods of a charge. Conduction is transferring the charge by or via direct contact, while induction is a rearrangement of a charge with no direct contact, and it only takes place with conductors, because the same definition with insulators would be polarization. Coulomb's law. We defined Coulomb's law, and you can easily write Coulomb's law, which is F is equal to Kc Q1 Q2 over R squared, and you can say that Coulomb's law states that F is directly proportional with Q1 and Q2, or the value of charge, and inversely proportional with the square value of the radius, or I mean the distance. Newton's law of gravitation, it looks like Coulomb's law. It looks like that. It is equal to G m1 m2 over R squared. So you can say that the gravitational force is directly proportional with m1 m2, and inversely proportional, or the mass, and inversely proportional with the distance between the two objects. The units used to state the strength of an electric field. The strength of electric field is E, and the unit of E is Newton per Coulomb, so it is the unit. An atom with an extra electrons has what charge? Extra electrons means it has negative charge. Electric force factors directly proportional, and this is, as you can see, this is a stating of Coulomb's law. So electric force directly proportional with the electric charge, and inversely proportional with square the distance between the charges. Repelling force occurs between two charged objects when the charges are, and this is one of the properties of charge, when the charges are what? There is a repulsion, so they are unlike or different charges. And this, and if they are like, they will, repelling, so they are the same. They are like, or they are the same. If they are attracting, so they should be different. Is that the strength of electric field around the charge is equal to the strength of electric field. The strength of electric field is, once you see this word field, it is E. So don't be confused. Don't say that this is F because he said strength. No, F is an electric force. It is direct and it is clear. But when he says that an electric field strength, this is E, is equal to the force. So he's relating the E to the force. It is equal to the force divided by Q. So divided by the charge. Divided by the charge of the test charge. The charge. 2-point charge, initially 2 centimeters, moved the distance 6 centimeters. Again, he is trying to confirm your knowledge about Coulomb's law, and the distance was 2 and then it became 6. Compare 6 over 2 would be 3, which means 3 times increase in the distance, which means that the F is inversely proportional with 3 squared, which means it will decrease by a factor of 1/9. And here we have which of the following is true for both gravitational and electric force. So this is something common between electric and gravitational force. And if you can recall our previous revision, gravitational force and electric force are the same in one kind, that both of them are having here inversely square proportion. Both of them are inverse square with the distance, so it depends direct inversely with r square, but they are different in one particular property, which is gravitational force is always attractive while electric force is or could be attractive or repulsive. Okay, so which of the following best represents the difference between electric force and gravitational force? And again, this is the difference, and we said that electric force can be attractive and repulsive, while gravitational force is only attractive. Although this is not scientifically correct, but this is the thing that you need to know now, because gravity is not an attractive force. It is a bend in time and place. It is a bend in the fabric of the time-place. The magnitude of the electric force between 2 points, Q1 and Q2, the magnitude of the force, it is F. It is Q2 and Q3. So Q2 and Q3, you need to select the law that has Q2 and Q3 law, which is Q2, Q3 over r squared. So this is wrong and this is wrong and this is wrong, because they are not particularly mentioned, two Q's that you have. An electric force F exists between two objects both having Q if the charge on one object is tripled. This is wrong, it should be tripled, 3Q. What would happen to the force? Basically, the force would be also tripled. So if if one Q is tripled, the force is tripled. If both forces are tripled, for sure I will select this. If Q1 and Q2, both of them tripled, which means 3Q and 3Q, this would be 9Q. So the F will also be increased with a 9. Two charged objects are near each other. One of them, one has a charge of this coulombs, and it is a negative charge, so this is a negative charge, and the other has a charge of negative also. If the first charge doubles and the second charge doubles, so here Q1 and Q2 are doubled, this means that the force is going to increase by a factor of 4. State the different methods of a charge, and we mentioned this before. Different methods of a charge could be conduction, induction, and polarization. And you can go to our previous revision to define both. One more thing, if we wanted to define the meaning of the equipotential. Equipotential, again, if you have 2 points and the 2 points are having the same potential energy, this means that the potential difference should be equal to 0. and potential energy, which we referred previously as W. If W, if the 2 points are having the same W, the same potential energy, this means that the potential difference is 0, and these points are called to be in equipotential, which means that they have equal potential energy and 0 potential difference. This is very important. This is a quick revision for the theoretical part. I hope that this part was clear and somehow helping you in grasping most of the facts. Again, if we wanted to focus on the problem part, all of the laws that you need to know will be written here. So let's change the color. Let's do this here. You have 6 physical quantities basically. First of all, you have electric force, you have electric field strength, you have electric potential energy, you have electric potential difference, you have capacitance, you have Coulomb's law, Ohm's law, and finally you have the power law. Electric force is mentioned to be F, which is equal to Kc Q1 Q2 over R squared, and this comes in the drawing part. And electric field strength is E, which is equal to F over Q, and this comes in the word problems, but the part which is related to Kc Q over R squared comes also in the drawing part. So you are going to use this in the drawing part. Electric potential energy W is equal to F times R, which is F electric basically, or EQR, measured in joules. This is measured in Newton per coulombs. This is measured in newtons. Electric potential difference and energy, do not be confused between both. So difference is electric potential difference, which is delta V or V, which is which is W over Q. And if you divided W over Q, this means that you are going to remove this Q. So it would be ER. And it is measured in volts or V. Capacitance, C is equal to Q over delta V. And it is measured in farad or coulombs per volt. Coulombs per volt. As you can see, there is coulombs here and there is volt here. So it's coulomb per volt. Ohm's law, it is V equals to I times R, and you can draw this here, VIR, where V is in volts, I, which is the current, which is measured in amperes, and R is the resistance, which is measured in ohms. Finally, the power is measured or calculated by VI times V. Sometimes I need the power, and the givens will be the I and the R, and there is no V. So you need to get the V first by multiplying, by using Ohm's law first, and then you'll use the law of the power at the end. So these are all of the laws that you need. Problems, in the word problems, everything will be direct. For the drawing, you need to use Pythagorean theorem and the functions. I believe that these are the important parts that you need to focus on. If you need anything else, please post a comment to this video. It is very important. Here we didn't mention the powers unit, which is watt. Here this is amperes and this is volts. I would suggest that you rewrite them in your own way. Do not forget the units. And as I told you before, defining these values is so easy because you just look at the law and you say it in words. For example, the electric force. What is the electric force? It is the attractive or repulsive forces that directly proportion with Q1 and Q2 and inversely proportion with R squared. If you needed to define the electric field strength, electric field strength is a value that depends directly on the force, electric force, and inversely with the amount of a charge. Electric potential energy. Electric potential energy is an energy of an electric charge due to its position in an electric field. It looks like the potential energy in mechanics. Electric potential difference. This is something that you need to do because you need to change to make a different position. So it is the work done to change the position. That's why R here is important. Capacitance. The capacitance is the ratio between the Q over delta V, or the charge to the electric potential difference. And it is the ability for a capacitor to store charge. Ohm's law, it's a relationship between potential difference and a current and the R, and it is so obvious that voltage or the potential difference is directly proportional with the current and directly proportional with the R. And you can recall this drawing that we have mentioned previously. As you can see, that the voltage should increase if the amperes or the current is huge, and also it should increase if the ohms or the resistance is high. And the power is the current multiplied by the voltage. So these are all of the physical quantities that you need to calculate. I hope that this presentation was beneficial for you. Please post comments or questions to this video. Share it with your peers, please. And if you have any more suggestions or questions, comment to this video. Thank you very much. This is Shadi Al-Qassas, physics teacher and head of science department, Sharjah American International School.